Do you want me to introduce you to the attendees, or do you want to do it yourself?
I mean, you can do.
Since I do not know how to pronounce
I
the name,
mean, it's fine. You
yeah.
can, but I mean, you can just say like a sentence or two, and you don't need to. You can just use Tomaz. We'll be presenting about knowledge graph
Oh,
chatbots, and then I'll just say
okay.
thank you, and I'll take it over.
Okay. Okay. Sure.
I can't share screen. Hmm.
The attendants are increasing. Let's wait for 1 minute, and then we can.
Okay.
Okay. Okay. Hello. Hello to everyone. Welcome to Notes 2023. We have our speaker, Tomaz, if I'm pronouncing it right, to talk about knowledge graph based chatbot. So, yeah, Tomaz, you can go ahead.
I just can't share my screen while there's
Yeah.
something else
Okay, wait.
on the screen. Okay, give me a second. So, there's always some technical problems, but now hopefully you see my screen. So, as Isha mentioned, today I'm going to be talking about knowledge graph based chatbots. And let's just get into it. So, my name is Tomaz. I'm a graph and since 2023 also an LLM enthusiast. I write a bunch of content on my Medium blog post, but I have also just finished a book about graph algorithms for data science, and I managed to secure discount code for you, 40% off, that you can use if you want to get my book at 40% discount. So that's it for marketing, and now let's get into chatbots. So in nowadays, whenever you say the word chatbot, that usually means that there's an LLM, so a large language model, under the hood, generating answers and doing all sorts of things. So LLMs became popular around a year ago with ChatGPT, right? There was this big hype, but we soon realized that LLMs ChatGPT is quite great, but it has the knowledge cut of that. So the knowledge cut of that is basically that it's aware only of the event that occurred in its training data. So if ChatGPT is trained only until on data only until September 2021, then when you ask it a question about an event in 2023, it won't know the answer to that. And then the other problems are also the so-called hallucinations, where basically LLMs they are trained to always give assertive answers, right? But those necessarily aren't correct, right? And the most obvious examples where hallucinations, like to spot hallucinations, are usually when you ask an LLM to give you like an URL or to cite a scientific paper. You can see that then if you click on the actual link, you will get a photo false. So basically, the page does not exist. And there's like another like limitations is that when you're asking the LLM for the question or like for some information, you don't really know where that information came from, right? And obviously, the LLM wasn't aware of like private information during the training. So, for example, let's say you want to build a company chatbot, and you have some private information you want to include in the chatbot. Since ChatGPT is not aware of that information during its training, it just won't know the answers to those private questions. So at first, what we've seen is how to overcome the problems is that basically at first people thought we're going to be doing a lot of supervised fine-tuning of LLMs. And basically supervised fine-tuning of an LLM is where you give an LLM question answer pairs, and basically you ask it to train. Basically, it's to how you say customize it for the domain specific use case, right? But what we've seen or what is shown is that basically fine tuning is not really a great fit when you want to introduce additional information to the LLM. Even if you look at his copy from the Vertex AI from Google, right, about fine tuning, and they say currently model tuning may not improve the model's general knowledge. And also, I've seen from other people is basically that also that LLM, like fine tuning LLMs, is not like the primary focus is not really enhancing its internal knowledge, but other things like stylistic changes and other. So what has shown to be like the answer to most of those problems is the so-called retrieval augmented generation. This is like the most popular acronym. And basically, the retrieval augmented generation is where you basically present relevant context to the LLM in the prompt, and then you, at the end, you ask a question, the LLM, and then the LLM tries to use information from the provided context to answer the given question. So here in this example, let's say I've provided context to ChatGPT here that Nicola has won the NBA Finals MVP in 2023, and I also gave it what's the source, and then we the question is who won the NBA Finals MVP, and then now the LLM can construct a valid, up-to-date answer that doesn't have the limitations of the knowledge cutoff, right? And now it can answer questions about events in 2023. Now, obviously, here's the retrieval augmented generation is only as good as the provided context that you give it. So if the context is not good, then the answer will not be good. So it's basically the same thing as in our machine learning, so that garbage in, garbage out, and good things in, good things out. But basically, this is what I would say is like 90 to 95% people are doing today with LLMs is basically providing additional context at query time and then trying using LLMs to generate the final answer. So here's like a simple diagram of the architecture. So you have the user asking the question, and you have your smart search model, and the smart search has to somehow find relevant information based on the question, right? So for here in this example, if it was who won the NBA Finals MVP would be the question. The smart search would somehow have to find relevant documents that describe the information needed to answer the question. So in this example, it would be some sort of NBA articles or something. And then those articles are basically retrieved from the knowledge base and passed to the LLM. And now the LLM has the question, it has the user question, it has the relevant documents it needs, and now it can generate an up-to-date, valid answer, and it can also provide the source of information, right? So basically here it said the source of this information is official NBA news, right? So it's very transparent, and you can check how LLM came up with the answer it did. So the first type of retrieval augmented generation application that we've seen was probably a couple of months ago. If you opened Twitter or LinkedIn, you have seen the chat video PDF applications. So the idea here is quite simple. You take one or multiple PDFs, you split them into text chunks. Remember that most LLMs have limited token space. So you can't just put in, let's say, if you were to buy my book, you can't just put the whole book into the prompt, right? Because it's too big. So you have to split it into text chunks. And then the text chunks get embedded and loaded into vector index. So here, because it's a Neo4j conference, we're using Neo4j vector index. And then the user interface, the application side, right? We have the user asking a question. The smart search tool finds relevant document using the vector similarity search. The relevant documents are fed to the LLM, and then the LLM can generate the final answer. So just a quick refresher, what's vector similarity search, right? So in vector similarity search, text gets translated to a vector. So like you have a vector value that represents the text, and then the vector value of the question gets compared to the vector values of documents, and usually then the cosine similarity between those vectors indicates how similar or dissimilar the question is to the documents, and then you just take the top k similar documents, and you feed that to the LLM as the provided context. So it's quite simple in theory. So because this is quite an important use case, right? So searching information through unstructured text, Neo4j added vector index in 5.11, so that's like a month ago or so, maybe a little less. So basically the vector index, vector similarity search is now an indexed operation in Neo4j, so that means that it can scale to millions of documents, right? So that you can like build your chat with your PDF or like chat with your documentation applications on top of Neo4j. So here in this example, I'm showing you a chat with your PDF application that we built for the Gen AI stack. So basically what you do, you just input the PDF gets processed and embedded, stored into the vector index. You ask a question. So here in this example, I gave it a chapter from my book. I asked the question, how are node embedding models useful? And then the generated answer is based on the provided information from the chapter in my book. And while this sounds like quite advanced, all the code needed to build this application is here, right? So it's only 20 lines of code, and like 10 lines of code is basically extracting information from the PDF, right? So we start by extracting information from PDF, splitting it into text chunks, storing it into a Neo4j vector, and now that you have the information Neo4j vector index, you can basically use it in a retrieval augmented generation. The nice thing why this code is so clean is because Neo4j has integrations with LLM frameworks like LangChain and Llama Index. Here in this example, for those of you who are more familiar, this is using LangChain, right? So we're using LangChain to split the text. We're using LangChain to input the data into Neo4j vector, and then we're also using LangChain to generate answers. So it's quite nicely wrapped inside of Neo4j and makes it very easy. Okay, but now because the chat video PDFs were like the initial applications, right, based on unstructured data like text, but the world contains more than just unstructured text, right? It also contains a lot of structured information that you could use to build or to power your retrieval augmented generation applications, right? So here, basically, knowledge graphs come into play because knowledge graphs are ideal fit to represent complex structured data. So, for example, here we can see a knowledge graph that contains Mona Lisa, which is a painting, and then we have the author, or how you say, the artist, Da Vinci, who painted Mona Lisa, and Mona Lisa is located in Louvre, and Louvre is located in Paris, right? So the information can be very complex. You might also call it heterogeneous, and also quite connected, right? Because usually lots of real world information is quite connected and complex. So knowledge graphs are great fit to power your to basically to represent structured information. And what's the difference between the vector similarity search and like the structured query language, like using structured query language in this example Cypher to retrieve information for retrieval augmented generation? Like there's basically just one difference, right? So it's again the same thing. User asks a question, And now instead of with the vector, we translated the user into vector, right? Vector representation of text. Now here, instead of translating into a vector, we translate the question into a Cypher statement, right? Um, and to translate natural language text into Cypher, we need to use an LLM. And then once we have the generated Cypher statement, we can use that to fetch relevant information from the database. And then again, once we have the relevant documents, like information, we can then feed it to the LLM. The LLM uses it to generate the final answer, and then the final answer gets passed back to the user. And now a bit more details. How do we generate Cypher statements that are used to retrieve information? So the default, the most basic way is you provide the LLM. In this case, we're using again ChatGPT with the schema information of the graph, and then you say based on the schema, based on the provided schema of the graph, use the schema information to generate a Cypher statement that answers the following questions. So here in this example, we have who is the CEO of Neo4j, right? So this question gets translated into a Cypher statement, and the translated Cypher statement is the following, right? It just matches an organization with the name Neo4j, expands the has CEO relationships, and then just returns the name of the person, right? That is that has the has CEO relationship. There's also the second approach, where you can provide it with examples. So how is here basically we say here's like an example that you should follow, right? So how is Emil connected to Michael? We give it a Cypher statement example that uses shortest paths to find the shortest connection between Emil and Michael. And based on that example, you can basically give it similar questions, and it will know, okay, in the example you've used shortest path, and now I also know that I need to use shortest path for these types of questions. And this is also, the few short examples quite also useful, because sometimes you have domain-specific lingo that the LLM is not aware, and if you give it examples how to translate domain-specific lingo to Cypher, like the more powerful models like GPT-4 are quite able to generalize based on the provided examples to the user questions. And then basically, again, it's the same thing in the retrieval augmented generation, right? You just pass the relevant information that you got from the database to the LLM along with the original question, and then the LLM constructs the final answer. And here is like a single slide for how to improve Cypher generation, right? Because the main, how to say, bottleneck in these types of application where you need a Cypher statement to query the database is generating Cypher statements. And there's like a lot of things that you can do to improve the accuracy of generated Cypher statements. So one thing that you can do is you can basically provide multiple relevant examples, right, in the prompt, but those relevant examples don't have to be static, right? They can be dynamically provided based on the user question. So based on the user question, find the most relevant Cypher examples and feed those into an LLM. And here, basically, again, we're using the vector search to find relevant examples. So that means in practice that you can have 1,000 or 10,000 Cypher examples. At query time, you use a vector similarity search to find the most relevant ones and feed them into prompt. And then the second improvement that you can do, because LLMs are aware of graph schema, but they're not aware of that database values, right? Because you can fit an LLM the graph schema, but let's say you have million nodes in your graph, you can't fit the LLM with million nodes so that it would know all the database property values, all the property values stored in the database, right? So again, what you can do as a sort of pre-processing step, you have again, you extract relevant entities or the values from the user text, and then you try to map them to database values. So here, if I give you example, it was right, who's the, or even this one, if I, let's see, who's the CEO of Neo4j, right? And then you could check how is Neo4j stored in the database. Okay, LLMs, at least ChatGPT kind of knows that Neo4j is a business organization, but like, is that stored as lowercase? Is it uppercase? Is it capital case or whatever, right? So you can use here, what we've seen is basically use full text index or keyword search to map data entities from the user question to database. So that's another thing that you can do. So all of these improvements are so-called, I've heard the term called dynamic prompting, right? Where you don't need to have dynamic prompt, but the prompt for generating Cypher statement gets dynamically created based on the user question. So when would you want to use Cypher statements, right? Generated Cypher statements? So the first use case is the so-called multi-hop question answering. So a multi-hop question is either a question that needs to find information from multiple documents, or it's a question that basically can be broken down into multiple sub-questions, right? So if you ask, did any of the former OpenAI employees start their own company? You can break down this question into two sub-questions, right? And the questions are, first you have to identify who are the former employees of OpenAI, and then the follow-up question is, did any of them start their own company? And if you're using only vector similarity search, right, what you'll see is the typical recommendation was to use vector similarity search in combinations with agents. So basically you have the agent, it makes a plan. Okay, I need to this information, that information to answer the question. But if you're only using vector similarity search, the problem with information that is spread across multiple documents, that there's no guarantee that you will get all the relevant information. Because, for example, the former OpenAI employees information about that can be spread across multiple documents. And then also which companies they started is also, again, a bunch of companies. So you can have problems like repeated information in the top end documents, right? So for example, it just finds a subsection of relevant information, not all of that. And it's also hard to define how many documents you need to retrieve. And lastly, since it's a multi-step way, it's gonna cost more and the latency is gonna be bigger, right? Because there's multiple steps involved. So what you can do is basically build a graph from those documents, right? So here we take the documents about OpenAI employees and their startups and build a knowledge graph. So here, instead of doing all the bulk work, at query time, where we were using agents and doing multiple steps, we're basically moving the bulk of the work to the ingestion time, right? Because you need to somehow extract the information from the text to the graph. And that's, in this case, here's a link. You can also use LLMs, but it's a bit more costly, right? Because with vector similarity search, all you do is just do embeddings. But if you want to build a graph, it's a bit more expensive. But the solution is that then at query time you don't have the problems that you had before, because answering the question which of former OpenAI employees that founded the company is basically just a simple Cypher statement, and there's a lot of problems that you don't have to worry about. And the second use case that I see is the so-called real-time analytics, right? Because again, vector similarity search is not a good fit for doing any sorts of aggregations, transformations, or like graph analytics, like we had before the shortest paths, right? So this is the second use case where I see that having structured information is very good. So for example, answering questions, how many new customers we had last week, and similar. I'm running quite short on time, so I'll just walk you through. And like what use case I had is basically that you can use this basically to build a DevOps chatbot that can answer basically questions based on the structure of your cloud and other information. And basically, to sum it up, basically what I see is the future of retrieval augmented generation applications is basically you want to have a combination of both of unstructured data and structured data, and because basically that's how you get the full power, or like the full capabilities to power your knowledge graph. So it's not like one is better than the other. It's just there are use cases where unstructured text is better than there are use cases where structured information is better. But most of the time, I see that probably you would want to have a combination of the two. And that's it for my talk. I also have a book to give away. So let me just find this link. If you follow this link, you can basically get into a raffle, and I'll be giving away 5 books tomorrow. So if you just put your email there, I'll select 5 winners, and I'll give you a free book. So that's it. I don't know if you have time for questions. Okay, I don't know, but I'll assume that we don't have time. But you can contact me via email or Twitter or anything, and I'll be happy to answer your questions. You have some on the QA. Let's see. How does the Neo4j vector index create the graph relationships from PDF chunks? Need to be hard-coded defined. So the vector index doesn't really create relationships. It kind of imitates what vector databases do. You have a single node, and like one property of the node is the embedding, and then the other is the text. And you can just use the retrieve text, but you can also, since you're dealing with a graph, you can also traverse those relationships, right? But you have to build those relationships first. So by default, like the default integration that we have with LangChain and Llama Index, they don't create any relationships if you're using vector index. But if like manually you have some custom ideas what you want with the knowledge graph to do, you can add relationships, and then at query time you can also traverse those relationships. Are there any natural language to Cypher queries data set available? At the moment, no. But I should hope that they will pop up, right? Because we would like to move to smaller local LLMs for Cypher generation. Let's see. Will that work decently only in English or any language of our preference? Let's say we have a book in German and wanted to ask questions in German. So that will work. I mean, first of all, depends which types of embeddings that you use. So if you use OpenAI embeddings, it's going to work quite well in German as well. So basically all the supported languages in the embeddings will be supported for question answer generation. And also then again, you need to have an LLM that speaks German. So and OpenAI like ChatGPT also speaks German. So you need to have both of the embeddings and LLM that speaks German, and then it will work just fine. I'm interested in smart chunking of HTML files, especially providing context of the whole HTML and prior XP. Do you recommend hierarchical schema or rich p vector to have that context? So I just did that. I'm gonna publish a blog post next week probably, but you can have both, like LangChain called that parent document retriever, where you embed the children. In that case, it would be like the p tags, right? So the children are used for embedding and to find relevant documents, but then retrieved are the parent documents. In your case, it would be like a bigger HTML page. You can take a look at parent document retrievers in LangChain. Maybe Llama Index has them as well. But yeah, usually you want to provide more context to the LLM so that it can generate the answer more accurately. Okay. And yeah, that's it for me. I hope you guys enjoyed my talk. And if you have any questions, like I said, feel free to ping me on any of the social media or on email, and I'll be happy to talk. Thank you, and have a nice day.